gentlemen, I'm pleased to welcome you here at the Technical Forum at the group exhibit Hydrogen Fuel Cells and Batteries. Come in, join, hear the presentations, have a drink on the house, have a seat. Yeah, our next presentation is dealing with the topic PureCell fuel cell system, global opportunities and application. And it will be held by the Chief Technology Officer from ClearEdge Power, Mr. Zakiul Kabir. Give him a big hand, please.
Thank you for that kind introduction. Good afternoon, everybody. We'll talk about the PureCell fuel cell systems, the global opportunities, and highlight on some of the applications that we're going after with this awesome product. First, let's talk a little bit about our company, and we call it ClearEdge Power by numbers. Numbers speaks volume. I can't see the screen very well from here. Oh, this is a better one. So first of all, we're the only company, I believe, that we have experience with all 5 major electrolytes. That includes phosphoric acid, PEM, molten carbonate, solid oxide, and alkaline. We are the only company that currently guarantees a 10-year fuel cell and fuel processor life. We have more than 50 years of experience with various types of fuel cells. We have more than 300 very, very innovative employees, and we have sold more than 500 systems all over the world. And our fleet has accumulated more than 11 million operating hours. These are not kilowatt hours, but actual operating hours in the hands of real customers. The ClearEdge brand was established in 2003. Currently, our headquarters is in Sunnyvale, California. We acquired UTC Power last year in February, so a little over a year ago. Currently, we have 2 facilities for engineering and manufacturing. Our engineering manufacturing primary facility is in South Windsor, Connecticut, where we have consolidated the manufacturing of both Model 5 as well as Model 400. And then we have other US offices in California. We have global presence in South Korea and Austria, and looking at other areas to expand over the coming few months and years. Our company management system is certified to ISO 9001 and 14001. This is a timeline of our various product and technology related experiences. As you can see that we have done molten carbonate, and we have done phosphoric acid, PEM, alkaline, and solid oxide fuel cell. The alkaline fuel cell was an interesting application because that was the fuel cell that was used for the US space program. All of the US manned space vehicles always were powered by our fuel cell systems, including the space shuttle program. And in the space shuttle program, I was told that this fuel cell system was the single most dependable subsystem in the entire program, with no failure in the entire history. The phosphoric acid technology is the one that we are commercializing now for stationary application. So my talk will focus primarily on that technology-based applications. So we have 2 products, as I mentioned. Model 5 is a 5 kilowatt machine. Model 400 is a 400 kilowatt machine. We see a lot of commonality in the market space. In the middle is the market we're going after primarily, and we find that both Model 5 and 400 have equal opportunities in this segment. This includes technology centers, university campuses, office buildings, retail locations, utilities, and mixed-use hotels, hospitality, etc. And then there are applications where they need more power, so 400 kilowatt is a better application there. This includes healthcare, hospital, industrial, life sciences, etc. And the same goes on the smaller segment. With the Model 5, we're going after the multi-unit residential settings as well as small restaurants. These are some of our customers right now. As you can see, this represent a array of global companies, including Fortune 50 companies, various universities, etc. And this customer base, some of these customers are repeat customers and have been with us for 15, 20 years. And I'm very proud to report that Verizon, as you can see on the left-hand side top, they are the leading mobile and telecommunication service provider in the United States. They started using our 200 kilowatt machine, I don't know, maybe 20 years ago, and the machines performed so well that they came back, and when we introduced our 400 kilowatt machine, they are our biggest customer as we speak in the United States. We have global presence. This chart currently reflects our experience with Model 200 and Model 400. Model 200 was a 200 kilowatt machine that we discontinued a few years ago. And as you can see that our concentration has been in North America, obviously, and significant presence in Europe with Model 200, and we have a lot of units in Asia. And we are looking at opportunities in different continents and obviously in different countries, including in Europe. Some of the product attributes, the model, actually, I have an error in the heading. It should read Model 5. Model 5 is a 5 kilowatt baseload electric output. It produces about 21,000 BTUs per hour of heat. Electrical efficiency, beginning of life is 40% on a lower heating value basis. In a CHP mode, the overall efficiency peaks at 90%. Some of the important features which differentiate our fuel cell system from perhaps every other technology of this kind is we can very proudly claim that we have a fuel cell stack that lasts for 10 years or perhaps longer. And what that means for customer in dollars and cents is for the same hardware, they can generate 3 times more kilowatt hours, which is money. The system also lends itself for multi-unit installation. We can provide continuous power in the event that there is a power outage. The inverter has the smartness to be able to detect that there has been a power outage and then transitions from grid connect mode to grid independent mode, and the transition takes place in 8 milliseconds, so the customer does not detect any power outage. It uses low pressure natural gas, so no pressurization is needed. The pressure requirement is equivalent to a commercial, residential or typical pipeline natural gas, ultra low emissions. We're certified to ANSI FC1, and this model will soon be available. We are projecting about September, October timeframe with the CE certification and CE mark, which would lend itself applicable in the European marketplace. The 400 kilowatt machine has similar attributes. It operates at 400 kilowatt baseload electric output, generates about 1.5 million BTUs per hour of heat. A fraction of the heat is available in higher temperatures. We call it high-grade heat, about 120 degrees Celsius. And the low-grade heat is available anywhere from 60 to 65 degrees Celsius. The high-grade heat at 120 degrees can be used for heating purposes, but some customers also use that heat for absorption chillers. And supermarkets are good examples where they operate these machines as combined heating, cooling, and power mode. This is an example of how our customers currently use the 400 kilowatt machine. As I mentioned, that the high-grade heat can be used for absorption chilling type application, and the low-grade heat can be used for any type of heating application. And the application and the markets, these are quite obvious, so I don't want to repeat them. You can read them at your leisure. This is an interesting chart. Fuel cells are not to the point where they make immediate economic sense. So we take advantage of some of the incentives that are available in the United States. This particular case study represents the incentives available in California, along with the federal tax incentive. And as you can see, that when you take into account the availability, the power generation capability, and when you factor in the incentives, even at the relatively high price of today, the customer has a payback period of less than 5 years. And when your machine can operate for at least 10 years, this still makes a pretty good economic sense. The machines can be installed indoors or outdoors. So we have some examples here, and they are modular. So you don't have to install the entire power capacity that you may need in the future. You can grow into your future need as the need arises. So you can have one machine to multiple machine. In this side of the picture, we show currently our largest installation in Korea. That represents a 5 megawatt installation, whereas these machines are each 5 kilowatt, and in this particular case, this represents a 15 kilowatt installation. The flexibility of installation allows the machine to be in your basement, in the back of your property, in any location, including on the roof of a building. We make sure that our customers have the ultimate worry-free experience, and hence we make sure that we monitor the units 24/7, 365 days of the year, irrespective of where the machines are installed. The control center is manned with trained engineers, where they keep an eye on every parameter of every system all over the world, and in the event that they see something that needs immediate attention, they can do most of the maintenance or repair work, not maintenance, but most of the tweaking from this control center. But in the event that this requires some human intervention, they can dispatch real-time support and make sure that the units keep running without any disruption of power to the customer. What makes our technology that I believe is better than anything else out there? The number one is the durability and reliability of our system, and it has been proven. It's not proven by some laboratory experiment. We have data to prove that our stack technology will survive 10 years. So on the x-axis, we show the evolution of the technology over the years, and the y-axis shows what kind of stack durability we were able to achieve in that time frame. So around 2010, we were able to achieve 10-year life expectancy of the stack. And this chart is a very important chart, and we monitor this almost on a daily basis, which shows the stack voltage against the predicted stack voltage. So we have very sophisticated models to predict performance over time. And as you can see, that the data from the entire fleet shows that we are performing better than our analytical prediction, which means the analytical prediction shows the stack should survive at least 10 years, up to 4 years of real-world application and operation. We are still seeing that we are performing better than what we projected. So we feel very comfortable and confident that our fuel cell stack will survive at least 10 years and most likely longer than 10 years. And to verify that we were not fooling ourselves, we hired an independent engineering company to look at the data and do an in-depth analysis, and they agreed with our conclusion, stating that they believe the fuel cell technology that we currently have has a life expectancy of at least 10 years. The other attribute that we have that is kind of unique for a system that is of our size is the system's ability to follow load, electrical load. Here we show two applications where in this particular case, the customer has an electrical requirement higher than 400 kilowatt. So the system over the weekend operates below 400 kilowatt, but then during the weekday, the system reaches 400 kilowatt point, continues running, and in this particular case, the remaining of the power needed by this facility comes from the electric grid. And then on Friday night, when the lights go down, the fuel cell goes down to the required power level. There is a delta over here between the actual demand and the power generated by the fuel cell system, and this delta is dictated by that electrical grid over there where they have zero export control. So we have to maintain a 100 kW delta to avoid any power being put back into the grid. This is another application. In this particular case, the customer chose not to bring any power from the grid, and in this case, the system operates exactly in a load following mode. So this chart actually shows two lines. There's a black line and then there's a green line. One represents the customer's instantaneous electrical requirement. The other represents how the fuel cell system reacted to that actual demand. And as you can see that both lines overlap, meaning the system continues to follow the customer's actual load requirement instantaneously. The other feature that is unique for our system is its ability to operate independently, grid independently, in the absence of electrical power, which is very important typically if there is a natural event, weather-related event. There are a couple of examples here. In 2012, there was a big hurricane, Sandy, and in the Northeast, a lot of these cities lost power. Hundreds of thousands of people were out of power. Fortunately, that was not the case for 23 of our customers who were lucky and happy to own our systems, because the systems continued generating power through the entire power outage and the customer never lost power. And there are other examples where there were winter storms. And in this one particular case, in 2011, there was a big winter storm in October, which is very unusual. And it turned out that one of the high schools, South Windsor High School, which has a fuel cell system, was the only facility large enough and also had the power going. So that kind of became a emergency shelter for the town of South Windsor. And the same goes for various other applications, including supermarket. This was I believe, an A&P supermarket. And in that particular instance, they were very happy that they could continue their operation well, while in San Diego, there was a large power outage. So some of the applications. So who are buying these systems and why are they buying this system? So this is an example of a hotel. It's a hotel in San Diego, California. And this particular case, this hotel has 8 Model 5 systems indoors. As you can see, they're installed indoors. And the heat is utilized in the swimming pool. So in addition to saving money on their electricity, they are able to maintain a very warm 80-degree Fahrenheit temperature of the swimming pool, which I'm told is a big attraction for the tourists for staying in that hotel, because they can take a swim around the year. Another application over here, this is a Oakland Hill Tennis Club. It's an athletic facility. In this particular case, they want to obviously reduce their operating cost. They want to control their electrical utility exposure and also use the heat for the swimming pool. In this installation, I believe we have 4 systems, and these systems are running quite well. Another application where the heat is used in the for some of the agricultural stuff they're doing here. And over here, they had 2 generations of the systems, and they continue to operate very reliably. I believe at this point, this set of systems are generating nearly 100% uptime without any failures. This is a new application that we're going into, and there we see a lot of opportunity for fuel cell systems like ours in this type of application. This is a natural gas well, where, as you can imagine, they use electricity there, and the fuel available is I call it raw natural gas. And this is our 5 kilowatt fuel cell system. And this is a very interesting application because the electricity is used to generate, used to operate this natural gas operation activity, all the while the water that is produced due to pumping of natural gas, which the well field need to process, and in the winter months they have to keep this, prevent this from freezing. So the fuel cell heat will be used to heat trace those water activity to prevent from heating. So it's a very good CHP activity, and our systems in the natural gas well are running with nearly 100% uptime. Some applications for the Model 400. These are particularly utility scale application. We can use our 400 kilowatt machines for grid stabilization, and the power electronics that we obtain for the 400 kilowatt machine from ABB ABB also provides additional features and additional add-on capability which we can integrate with our fuel cell system and provide grid stabilization. Then there are other applications like we can provide real power delivery with distributed system, and we can also provide reactive power, backup power for the customer, and heat recovery for potential sales to customers. This is another application where the real power is provided, reactive power is provided, and heat recovery. The heat is used for preheating of the gas pressure let down station in the event that there was a natural gas distribution setup. And this is perhaps a more common one where the heat is utilized for district heating system. This is a 5 megawatt installation where the fuel cell heat is put into the district heating system. So in summary, PureCell systems deliver energy savings, which is the most important attribute. We provide reliable power. We provide carbon, water, and pollution reduction, and provide a sustainable attributes like LED points, LEED points, lead points. We offer experienced management system, 24/7 service team, and we also provide options to purchase or lease. For further information and details, feel free to visit our website at clearedgepower.com. Thank you.
Thank you for this interesting and informative presentation. And I'm a little bit sorry because we are at the end of the time from this slot. So if you have any question, I think you are invited to come to the booth. It's quite close to this technical forum. It's this direction, and the booth number is D76. And I think you and your colleagues will welcome everybody and talk and discuss and answer your questions over there. Okay, thank you very much. It's your applause. Thank you. So we have a really short break now, and after this, please note the next presentation will be held in German, and the title is Brennstoffzellen in der Haustechnik, ein Demonstrations- und Lehrmodell für die Ausbildung.